Okay, so we are going to start our note catcher about geometry. And we talked a little bit about this on Friday. You also talked a lot about these concepts in elementary school. So two words that I hope are familiar to you are perimeter and area. And just to jog your memory, perimeter talks about the distance around something. So if you look in our classroom right now, do you see this black kind of, I don't know, trim? That's the word I've been looking for all day. Do you see this trim that goes around the bottom of the room? Okay, so that lines the perimeter of the room. Another cool thing about the word perimeter is it has the word rim in it. So if you're trying to think about, oh, what is that word? Okay, I have to find something that goes around the rim of the room. Okay. What was that word you used again?
Trim.
Trim. Okay, so we'll say the trim around the room. That's our little example. All right. Then we also have the word area. And that is the amount of surface inside a figure. So if we look in this room, what is covering the area of this room? Kayla? Carpet. The carpet, yes. So let's just write in carpet. Just so we have some real life examples of area and perimeter. All right. So for our first one up here, we have a rectangle. And we know that to find the area of a rectangle, it's the product or multiplying the length and the width. This particular one is 6 by 4. So if we wanted to find the area of this, we would say 6 times 4. Now what that basically means is, pardon me, we have 1, 2, 3, 4, 5, 6 groups. And each of those 6 groups has 1, 2, 3, 4 squares in it. So we have 6 groups of 4. So if we want to find our area here, what's our area going to equal, Crew?
24.
You're so close. Do you need to add something? Do you know what you need to add?
Centimeters squared.
Centimeters squared. You are exactly right. Or squared centimeters, because we have 24 in here. Let's just double check. I'll switch colors. 1, 2, 3, 4, 5, 6. Another group of 6 would be 12. Another group, there's 12. Another group of 6 would be 18. And another group of 6 would be 24. Now, counting these boxes is not very efficient. That's why we have a formula in order to do so. All right, so that's area. Let's switch gears and let's talk about perimeter here. I'm going to have a clean figure. Okay. Yeah.
You have to add this to the square.
Do you have to add what to the square?
Like, this 10% is squared, you could add it to.
Yeah, this little thing means squared. You could also write 24 on the word square centimeters. And you could do that as well. You'll see when we write perimeter how it looks, the label looks different from area. All right. Yeah.
I know how to do the perimeter.
Do you want to help me out? All right, let's hear it.
So what you would do is you would just add all of the centimeters up. So you would do 6 plus 4 equals 10.
Okay.
And you would do 10 plus 6 equals 16.
Sure.
And then 16 plus 4 equals 27.
I love that strategy. Can I do it a little differently so we see if we get the same answer? So Matthew just said 20, and he did 4 plus 6, which was 10, right? Plus another 6, which was 16, plus 4, which was 20. Awesome. I'm going to do my lengths, which are 6 plus 6. And I'm going to tell you guys, when I do this, and I want you to do this on yours as well, put a little check mark above the ones that you add. Because I cannot tell you how many times I'm looking at a student's work and they're like, wait, I got it wrong, but I can't find my mistake. And it's usually that they forgot to add a side or that they added a side twice. Okay? So this is a little strategy that will help you with that. Then I'm going to add the width. Okay? So 4 plus 4. Okay, let's see if we get the same thing Matthew had. I sure hope so. 6 plus 6 is 12, plus 4 is 16, plus 4 is
20.
Wait, 20. Okay. Phew. I thought I had the wrong answer for just centimeters for just a minute. 20 centimeters. You're right. Now this one is not squared because it's perimeter. So it's only in one dimension. It's not making squares this time. It's just finding the length of something. So we have centimeters squared for area and just centimeters for perimeter. You could have feet squared for area and feet for perimeter. Okay? And volume is a whole other thing we'll talk about later. Yeah, Keenan?
Doesn't make a difference if you take away this bit.
Then it would no longer be area. It would just be a distance that would just be 24 centimeters long, going in one direction.
Okay.
So it does make a big difference. Yeah.
Wondering if three-dimensional shape or is it cube?
It is cubed. We're exactly right. All right, I'm going to move this down just a little bit. And we're going to go back to those area models that you guys were pros at when you did your test. You did such a great job on your test. Now, if you didn't already make the connection, when you were doing an area model, you were finding area. So on this one here, we have 2.5, which I split up into 2.5. Then we did 3 1/4, which I split up into 3 1/4. Okay? So I already did 2 times 3 for you, which is 6. I already did 1/2 times 3 for you, which is 1.5. Okay? Will you guys help me out here with 2? I'm going to do 2 times 1/4 here. Ellis, what's 2 times 1/4?
1/2.
1/2. How'd you get 1/2?
I got 1/2 because multiplication is just for the addition.
Yeah.
So 1/4. So basically adding 1/4 to 1/4. That's 2/4 for 1/2.
I love that. I like that you're thinking of it that way. That's a great idea. How about 1/2 times 1/8? And see, what are you thinking for that one?
It's 1/2 times 1/4 for me.
Oh, did I say? Oh, sorry. Keep going.
It's 1/8.
Ah, I hate it when I spoil it. You're right. How did you get 1/8?
Just 1 times 1 is 1 and 2 times 4 is 8.
Yeah, so we have our dimensions, which are our length and our width. Dimensions is a word you should know. So that would be 1/8. Nice job. All right, you also know how keen I am about you writing number sentences. We talked about that on Friday. So I have a number sentence or an equation to find my area. So I have 6, 1/2, 1 1/2. I'm going to add 1/2 here. And I'm going to add 1/8 as my last section. I'm going to give you guys a minute to add that up yourself, and then we'll come back to it. All right, crew, what did you get for your area when you add up all of your parts? Julie, what'd you get? Awesome. I was looking over your work just from here, and it looks like that's what a lot of you guys got to. Any questions? I should say I didn't see anything else. Do you have any questions? Fantastic. All right, our next one is find the perimeter of the rectangle above. Okay, Harrison, what steps are we going to take to find the perimeter?
The perimeter, we need to add up all of these sides.
Can you tell me what your number sentence that would be?
That would be 3 1/4
Okay.
plus 3 1/4 plus 2 1/2 plus 2
Nice job, Harrison. All right. Take a minute, and I would like you to solve for the perimeter. All right, crew, I'm going to go 1, 2, 3, and I want you to whisper your answer for me. 2. Yes, 11.5. Good for you guys. Oh, wait, hold on. 11.5 what? Not centimeters.
Inches.
Inches is inches. Okay, these 2 lines up here, where it's like kind of looks like apostrophe, that means inches. Okay, so let's go down, and we're going to dig into some new stuff here. Okay, so we need to find the area of this complex figure. You might also hear it called a composite figure as well. So we need to find the missing length to find the perimeter. So we are missing the lengths for x and y. I'm going to show you how I find x, and then you're going to work to find y. So I'm looking for the value of x right here. I know that the entire vertical length is 5 centimeters. So I want to find this part right here. Well, this part right here is 2. So I'm going to subtract that from 5. Okay. You see how this is the same right here and right here? Okay. Above here, this is 1, so this distance is 1. So 5 minus 1 is 4. Minus 2 is 2. So the value of x is going to be 2. The length of this part right here will be 2. I would like for you to turn to the person next to you and talk about finding the distance of y. You can do that right now. All right, Kayla, tell us how you found the value of y.
So how I found the value of y is I knew that the bottom part of the composite rectangle
Good for you. Let's listen to all that vocabulary.
is 4 centimeters.
Okay.
And I see the top of the composite rectangle is 3 centimeters.
Okay, so the bottom was 4, the top was 3. Okay.
But if you look at it, I can draw an imaginary line from 3 centimeters.
Is this what you're talking about?
Yeah. And I see that the leftover sliver is 2 because I know it can't be 1.
Well, what is this? What's the distance from this right here?
That's 2.
Just this part right here.
Oh, that's 1.
Yeah, because it's the difference between 4 and 3, right?
Yeah.
So that'll be 1. Okay, how do we find the distance of this right here? How do we know how long this is? Keep going.
Well, if you can see the line right from, it's like on top. It's right next to one.
This one?
No, like one.
Right here?
No.
Yeah, come over to us.
Right here.
This one right here?
Yeah.
We have to keep going horizontally.
So we do.
Keep with horizontal distances. Yeah, how would we know that this, how do we find the distance of this little part here? JJ, what do you think?
Well, if you look above 1 centimeter here, and that's the size of 1 centimeter.
Yeah, so this is also 1. Awesome, so that means that 1 and 1, that would be 2. All right, here's our number sentence again. So we have, I'm going to fill this in, we have 2. Let's just check off all of our signs as we do this. So we have 2 plus 4 plus 5. It's going to be 2 plus 4 plus 5 plus 3 plus 1 plus 1 plus x and y, which we know those are 2 and 3. Oh, 2 and 2, I'm sorry. I love it when you guys pay attention that carefully. Okay, I'm going to give you just a minute to find the perimeter there. Maggie, what did you get?
I got 20.
Awesome. Yep. 20 centimeters. There we go. So we have our perimeter. Now let's talk about how to find the area of shapes. Okay, I want you to take your pencil and I want you to divide this composite figure into other shapes that you know how to find the area of. So I know how to find the area of rectangles. So I'm going to divide this up into different rectangles. I already worked before, and I know that the length of these two parts right here were 2 and 2. So that's going to help me here. Okay. I am also going to be a little bit picky about you being very precise about the area of each one of these pieces. So this one, for example, right here, if I'm trying to find the area of this, what I should see on your paper is 1 times 3 equals 3, okay? 1 times 3. So those are the dimensions of that. So the area of this part right here is 3. I multiplied my dimensions and then I circled the area, okay? I'm going to go to the one on the bottom right here. Lawson, what are the dimensions of this bottom chunk right here?
Is it 2 and 4?
Yeah, so I'm going to say 2 times 4. And that's 8, and I'm going to circle 8. That's the area of that chunk right there. Okay. Now I have this one right here. This one's a little bit tricky. Do you think you know, Matthew?
Yeah.
What do you think it is?
So I know that the 2 centimeters is the same size underneath the 5 centimeters.
Okay.
And then I know that for
Oh, what do you mean? Are you trying to find the length of this right here?
Yeah.
We know it's 2 because we have this over here, right?
No.
And we have 5 minus 1, which is 4, minus 2 would be 2. So this is 2, and we knew that because the other side too. Oh, we have to find the length of this. Yeah.
I think that it would be 2.
How come?
If you see that, it's half of 4 centimeters. So half of 4 is 2. So,
Now let's be careful with just eyeballing it. What like definitive proof do we have?
well, can we cut it into vertically?
Sure.
So if you cut from the line, if you cut vertically down, it's exactly 1/2.
You're right, it is.
So that's 2, and it's the same size as this line.
We have some other piece of info that's going to help us with this too. Alice, do you know?
Well, when you're multiplying, it's a complete square.
Okay.
So with 20, so 2 and 2 is 4.
Okay. This is what I want to show you guys. If we know that this whole distance here is 4, and we take away 2, then this part right here that's left over is going to be 2 as well. Okay. So that's what you should be looking for to find your exact. I want you guys to move beyond saying like, oh, well, it looks like half, or it looks like the same length as something else, because that's not always going to be the case. You can't always rely on that. So for this part right here, we're going to say 2 times 2, and that is equal to 4. All right, so going over to our number sentence here, we had 1 times 3, which was the top here, and that was 3. We had the square in the middle, that was 2 times 2, and that's 4. We had the bottom part that was 2 times 4, and that is 8. So if we add all that up, we would get 15 centimeters squared. Oh, you. All right, let's go to our next page, and you're going to see another really cool strategy here. All right. All right. So this one, we're going to find the area of an entire shape and then subtract from it. So take your pencil, and I want you to draw a box that would go around the entire shape. So draw a box that would go around that entire shape. So we're going to find the area of all of that, and then we're going to subtract out different parts from it. Okay? This is going to be this today. So the area of this whole thing here, okay, I'm going to multiply 5 times 4 to get the area of this entire box right there. And 5 times 4 is 20. Okay. Then I'm going to find the area of each one of these smaller boxes right here, and I'm going to subtract those out. I'm going to take those away. So based on the numbers that I had from the previous shape, this is the same shape. We knew that this was 2, and that length was also 2. So we can say that this square here is 2 times 2, which would be 4. We have this little shape up here, and we figured out these dimensions before, but we could say 1 times 1, so that's going to be 1. And if we have 20 minus 4 is 16, minus 1 is